Hi guys, welcome to Algorithms Made Easy. In this video, we'll see the question simplify path. Given a string path, which is an absolute path starting with a slash, to a file or a directory in a Unix style file system, we need to convert it into a simplified canonical path. In a Unix style file system, a period refers to current directory, a double dot or a double period refers to a directory that is one level up, and any multiple consecutive slashes are treated as a single slash. And for this problem, any other format of a period like a triple period or any other number of periods other than single or double would be treated as the name of a file or directory. Now we need to convert it into a canonical path, and this path has the following format. The path starts with a slash, any two directories are separated by a single slash, and the path does not end with a slash. The path only contains the directories on the path from root directory to the target file or directory. That is, no single period or double period should appear in my canonical path. We need to return the simplified canonical path. In the example 1, we have slash home slash. So the simple canonical path over here would be just by removing this trailing slash that is given in the rules for forming a canonical path. In the second example, we have slash dot dot slash. So here we just return slash as we cannot have a dot dot and we cannot have a trailing slash. Now in the third example, we have a slash home double slash foo slash. So here we'll just have slash home slash foo in our simplified canonical path. The fourth example is a little bit tricky. So here we have a slash a. So we go into a directory A. Then there is a slash dot, that is we stay in that directory. Then we have a slash b, that is from A we go into an inner directory which is slash b, and then there is a double period which means we are coming out of a directory. So we reach to A. We come out of B and we reach its parent directory which is A. Now again we have a dot dot. So we come out of A also and go to our home directory, and then from there we are going to directory C, and thus the output is just slash C. So now that we know the question, let's understand it better and see how to solve it. So here I have taken last example that was given to us, and here we can see that I have just considered slash A for now, and so I go into the A folder from my home directory. After that I have a dot which will do nothing, and then I have a slash B, that means I am going into a directory B from A. Now I have a dot dot, so I come out of this directory and go to A. So I am currently on A. Then again there is a dot dot, so I come out of this A and I am at my home directory right now. After this I am going to C slash C. So from home I am going to C. So my simplified canonical path will not contain all these operations of going in and coming out. It will only contain this slash C, that is from home, the directory I am in. For that the simplified path is slash C. So that is my answer. Now what are the operations that we are doing here? We are doing a pushing and popping operation for the directory names based on the rules that are given. So now what are the rules? The two main rules are that whenever we encounter a double dot, we pop or we come out of that directory, and whenever we get a name, we push in or we go into that directory. So we are only concerned with these two rules, and rest all doesn't matter to our problem right now. So what is the data structure that can be used? We can use a stack or we can use a doubly ended queue. Now let's see how we would do it using both these data structures. I'll show you both of them at once itself. So I'm taking a doubly ended queue over here and I'm taking a stack over here. So let's see how these both approaches would differ. Currently or initially I'll be at my home directory, or that would be a slash. And then for these directories, I'll need to split the strings into the directory names or just the operations that are going to be performed. So I'll split this with slash, and that would give me this array. So this would be an array of string. Initially I'll be at A. So the first operation that I can see here is A, and since this is a directory name, that means I'm going inside the directory, and so I push it in my stack and queue. These both are two different approaches, remember guys. Now the other one is dot, that means we are just staying in that directory, so we do nothing. The other one now here is B. So since this is a directory name, we again go inside that directory by just pushing or adding those into our stack and queue. Now we have a ... and so we removed the last element. Remember, we are removing the last element because we want to traverse one level up. So I still have A in my stack and queue. Again there is a ... and so we'll remove both these A's from our data structures. Now the last operation here is C, which is a directory name, and so we push it in our stack and add it in our queue. Now here my steps end. After this, what I want is, I want the path. To calculate the path, there is a difference in the approaches. So in the doubly ended queue, we can just start from the front and keep adding slash with the directory name and all the elements that are present in my queue. In the stack, I would need to go in the reverse order, because when I pop from the stack, the highest one would get popped, but I need the lowest one first. So I need to append in a careful manner. So the difference between both these approaches is just while popping out the elements and creating my last result string. So now that we know these approaches, let's go ahead and see the code for them. Now let's start with a stack solution. In here, I'll need a stack and a variable in which I'll be building my result. Apart from this, I'll need to initially split my path into just the directory names. So this will split my path by slash and would give me only the directory names or the operations that are going to be performed on each step. So now I'll be looping on this string array and perform the push and pop as per the rules that are there. So in this for loop, I'll have two conditions, one for pushing and one for popping. So let's write down the simplest one first, that is for popping. That is, whenever I have two dots, I'll simply pop. And one more condition that would be while popping is stack should not be empty. The next condition is for pushing. So when I'll push, whenever I do not have an empty string, or whenever I don't have a single dot, or whenever I don't have a double dot. Let's just copy and paste it. So whether it is not empty or not equal to a single dot or not equal to a double dot, we'll do s.push p of I. Let's put an enter, and that's it. Once this loop terminates, the stack will only contain the elements that would appear in my simplified canonical path. So the base case here would be, if my stack is empty, I just simply return a slash. And if it is not empty, I'll need to iterate over my stack and append the elements in my string builder. That is my result. For appending, I'll be appending in the front rather than appending in the back, because stack would pop the last element first, but I need in the FIFO order. So that's it. After everything is done, return result.toString. So let's run this code, and it's giving a perfect result. Let's try to submit this. And it got submitted. The time complexity for this algorithm would be O of n, and the space complexity would also be O of n. So now let's change this code into a deque code. So here we'll take a deque, and this would be implementation for deque, that is linked list. In here we'll do a s.poll, and this would be s.push. That remains same, and the main change that is there would be in our while loop. Instead of this, now what we'll do is we'll append slash, and then we'll append the first element from the queue, and then again slash, and then second element from the queue, and so on. So what we need is result.append, first a slash, and then s.poll last. This would give me the first element from the queue. Finally, we return result.toString. Let's run this code, and it is giving a perfect result. Let's submit this, and it got submitted. The time and the space complexity over here still remains the same. that is O of n. We can make this for loop more readable by taking string s in path in P, and then we can just do if s dot equals, and this will also become s dot equals, s dot equals, and s dot equals. And since we have this dot dot condition over here, we can remove this from our second condition. So okay, that's it. Let's again run this. Okay, so we need to give another name, and this would be str. Let's rename everything, and here we'll put str. So let's run this again, and it's giving a perfect result, and let's submit this. So this is a better version for our previous code. And so that's it for today, guys. Hope you liked the video, and I'll see you in the next one.